Imagine you're embarking on a journey, and your vehicle is the AI strategy. Now, without a solid road beneath, that journey could quickly become perilous. This road in our story is the IT infrastructure. It's not just a technical support system, it's a strategic pathway that ensures your AI initiatives can travel smoothly and reach their destination efficiently.
That makes sense. So it's not just about having the infrastructure, but about making strategic choices that align with the broader goals of the organization. A misstep here could lead to costly detours, right?
Exactly. If infrastructure is underestimated or treated as an afterthought, organizations often find themselves stuck, facing delays and unexpected costs. The road needs to be well planned and maintained to support the vehicle's journey. In this case, the AI's path to transformation.
So it's about making sure the infrastructure is ready to support AI at scale. But how do organizations actually align their infrastructure with AI needs?
That's a crucial question. As we look ahead, the next part of our journey explores how AI integration transforms the very nature of infrastructure itself. It's not just about laying a solid road, it's about building one that can adapt and grow with the vehicle's needs.
Which sounds like a big shift, not just in technology, but in mindset. How do organizations start to make these transformative changes?
Well, it begins by identifying the specific demands AI places on infrastructure. Say, the computational power, data storage, and real-time processing needs. Once these are understood, infrastructure can be designed to be both scalable and flexible, ready to evolve with AI advancements. This is where the journey gets really interesting as we delve into creating an infrastructure blueprint that guides these changes.
So the next step is crafting that blueprint, which sounds like the map for our journey. How does this blueprint influence the implementation and monitoring of infrastructure?
The blueprint becomes the guiding document that outlines how to construct and evolve the infrastructure. It informs the implementation plan and performance metrics, ensuring everything stays on course. As we explore this next chapter, we'll see how these elements come together to create a reliable, adaptable infrastructure that supports AI's long-term success.
I see. So, understanding and planning for these requirements not only keeps the journey smooth, but also ensures the vehicle, our AI strategy, can reach its destination effectively.
Precisely. And this brings us to the starting point of designing a strategic infrastructure that aligns with AI initiatives, setting the stage for sustained organizational performance. Let's dive into how these transformative changes unfold. Imagine you've just planted a seed for a new AI initiative within your organization. To nurture this seed, you need fertile ground, an IT infrastructure that aligns seamlessly with AI demands. This means crafting a robust framework that supports the intensive computational and data processing needs of AI systems, much like ensuring a garden has the right soil and sunlight for growth.
Right, and just like a garden, this infrastructure isn't static. AI brings transformative shifts, requiring us to redesign how data flows and systems interact. We must be prepared for these changes to truly harness AI's potential and maintain operational agility.
Exactly. It's about anticipating growth and ensuring our infrastructure is scalable and flexible enough to adapt without a complete overhaul. This foresight reduces complexity and cost over time, much like planning for a garden to accommodate new plants each season.
And with a structured implementation plan, we can carefully monitor and adjust our infrastructure, ensuring it remains robust and responsive. This proactive approach prevents issues from escalating and keeps everything running smoothly like a well-tended garden.
But knowing this isn't just a technical endeavor, it's a strategic business imperative. Organizations that don't align their infrastructure with AI risk bottlenecks and inefficiencies. So the real question becomes, how do we ensure our infrastructure is both scalable and flexible to support these AI workloads effectively?
Which brings us to an important consideration: the role of cloud computing in providing the necessary scalability and flexibility. By leveraging cloud platforms, organizations can dynamically allocate resources, ensuring they meet fluctuating demands without the constraints of traditional infrastructure.
Exactly. As we explore this further, we'll see how cloud solutions enable organizations to respond to AI's variable demands efficiently. This adaptability is key to sustaining AI-driven value creation. So, let's delve into how scalability and flexibility can truly transform our IT infrastructure landscape. When we think about IT infrastructure for AI, scalability and flexibility become the unsung heroes of the story. Imagine a bustling city that needs to expand its roads and utilities as its population grows. Similarly, organizations need infrastructure that can grow or shrink with their AI demands without causing traffic jams or wastage. That's where scalable and flexible infrastructures shine, allowing businesses to adapt swiftly to changing needs and avoid costly bottlenecks.
Exactly, and cloud computing is like having access to a vast highway system rather than being stuck with a single road. It offers organizations the ability to tap into powerful resources on demand, much like renting additional lanes on a highway during rush hour. This not only accelerates AI deployment but also keeps costs in check, avoiding the heavy investment in fixed hardware.
And with dynamic resource provisioning, it's like having a smart traffic system that adjusts the flow based on real-time conditions. This ensures that AI applications perform optimally without overloading the system or wasting resources during quieter times. It's a delicate balance, but crucial for keeping operations efficient and agile.
But before embarking on this journey, organizations must map out their route by assessing their computational needs. It's akin to planning a road trip, knowing how much fuel you need, the best routes to take, and where to stop along the way. This ensures that the chosen cloud solutions align perfectly with their AI ambitions.
And once on the road, continuous monitoring acts like a vigilant GPS, guiding the organization through the twists and turns, ensuring that resources are scaled dynamically to meet AI demands. But here's an intriguing thought. What happens when the road itself needs to be more than just flexible and scalable?
That's a great point, Sarah. Sometimes the journey demands not just flexibility, but raw power and speed. This is where high-performance computing, or HPC, enters the picture. It's like upgrading from regular roads to high-speed railways for AI workloads. But how does one choose the right tracks and engines for this accelerated journey? That's the next part of our exploration.
High-performance computing, or HPC, is like the engine room of a ship, powering the complex AI workloads that drive innovation in organizations. Imagine trying to run a marathon without training. That's what AI models face without the robust support of HPC. By leveraging GPUs and TPUs, we can accelerate these models, allowing them to handle vast amounts of data swiftly and effectively.
It's fascinating how GPUs, originally for graphics, have become indispensable in AI due to their ability to process thousands of tasks simultaneously. And TPUs take it a step further, designed specifically for the unique demands of AI, making them a powerful ally in large-scale operations.
Exactly. And HPC clusters bring it all together, acting like a well-coordinated team, distributing tasks to ensure everything runs smoothly and efficiently. This scalability is crucial as AI models become more complex and data volumes grow. But as with any powerful tool, careful planning and ongoing optimization are vital to harness its full potential.
So organizations need to align their HPC infrastructure with their AI needs, ensuring that resources are neither underutilized nor overburdened. It's about finding that perfect balance to maintain performance and drive AI success. But once we've got our computing power sorted, it naturally leads us to the next puzzle.
Right, because having the computing horsepower is just one part of the equation. The next critical step is managing the data itself, the very fuel that powers AI systems. How we handle, store, and process this data can make or break our AI initiatives. And this brings us to the starting point of our next discussion: effective data management and storage strategies. Imagine you're running a bustling kitchen. The ingredients are your data, and how you store and manage them determines the quality of every dish you serve. Effective data management ensures that your ingredients are fresh, securely stored, and accessible whenever needed. If you mismanage them, you risk serving spoiled dishes, or in the case of AI, producing unreliable outputs.
Exactly, Sarah. And just like a kitchen needs to scale up during busy times, data storage systems must be scalable and distributed to handle growing data volumes without any hiccups. They ensure that as your AI initiatives grow, your data remains available and reliable, preventing any out-of-stock situations.
And to keep everything running smoothly, data processing frameworks act like your kitchen's workflow, ensuring that data is efficiently transformed and analyzed, much like prepping ingredients for the final dish. This structured approach helps maintain the speed and quality of your AI insights.
So, just as a chef assesses storage needs based on expected foot traffic, organizations must evaluate their data storage requirements with an eye on future growth. This foresight prevents any mismatch between demand and capacity, ensuring smooth operations.
Precisely. But as we fine-tune our data management strategies, we must also think about where and how we process this data. This leads us naturally to the concept of edge computing, which is like setting up a satellite kitchen closer to where the action happens, allowing for faster, more immediate service.
Edge computing. It's fascinating how it changes the game by bringing computation closer to where data is generated. This approach is crucial for AI applications that need real-time responses, much like serving customers at the table without delay.
Which brings us to the starting point of understanding how this shift in infrastructure can revolutionize AI operations, especially in environments where every second counts. So, how does edge computing fit into your current AI strategy? Imagine a world where decisions need to be made in the blink of an eye, like a self-driving car navigating through traffic or a factory line adjusting to a sudden change. This is where edge computing comes into play. By bringing processing power closer to where data is generated, it allows AI systems to respond almost instantaneously, overcoming the delays of traditional cloud computing.
So it's like having a mini data center right where it's needed, reducing the time it takes for information to travel back and forth. This is crucial for applications that can't afford even a moment's delay, right?
Exactly. And beyond speed, edge computing enhances security by keeping sensitive data closer to its source and improves reliability by reducing dependency on continuous network connectivity. It's a foundational shift for AI systems that need to perform in real-time environments. But once you've identified the need for edge computing, the next step is implementing it effectively, ensuring all parts work seamlessly together.
Which sounds like a complex puzzle. With so many components to manage, from hardware to software, how do organizations keep everything coordinated and running smoothly?
That's where AI infrastructure orchestration comes into the picture. It's about automating the management and coordination of all these elements to ensure consistency and efficiency across large-scale AI operations. This orchestration helps organizations handle complexity, prevent resource conflicts, and scale their AI capabilities effectively.
So, in essence, just as edge computing brings processing closer to data, orchestration ensures that all these moving parts are in harmony, ready to meet the demands of growing AI workloads. It's like having a well-rehearsed symphony where each instrument plays its part perfectly.
Precisely. And this raises an important question. How can orchestration tools and strategies be leveraged to maintain the balance and efficiency of AI systems? Understanding this orchestration is crucial as we explore how it supports the scalability and reliability of AI deployments. Imagine you're managing a large orchestra, Rana. Each musician represents a different component of your AI infrastructure. Without a conductor, the musicians might play the right notes, but not necessarily in harmony. That's where orchestration comes in. It's like having a conductor for your AI systems, ensuring everything works together smoothly and efficiently.
I see. So, without this orchestration, it sounds like chaos could ensue. The musicians might step on each other's toes, leading to missed notes or even a cacophony instead of a symphony. Is that why tools like Kubernetes and Docker Swarm are essential?
Exactly. They help manage the complexity and ensure consistent performance across all systems. It's about creating a seamless performance where every part knows its role and resources are used wisely. This orchestration not only keeps everything in tune, but also ensures we're ready to scale up when the audience grows, so to speak.
And I guess it's also about having a plan in place, a roadmap for using these tools effectively to avoid any unexpected surprises. But once we've got our AI systems running like a well-oiled machine, what's the next challenge we face?
Well, just like an orchestra needs security at its venue, our AI systems need protection too. This leads us to a critical aspect: AI security and governance, risk and compliance, or GRC. As we introduce AI into our operations, the risks become more complex. So the question becomes,
How do we protect our AI investments and ensure they align with our ethical and regulatory standards? It sounds like the next part of our journey will be about safeguarding our systems while maintaining their integrity and performance.